Alright, so now getting into this video, what we're going to take a look at is going to be the what I describe as the fundamentals of fundamentals. So we're going to expand on what we kind of left off on in the last video and start going into a little bit more detail about being able to write statements in our programs. So in addition to talking about statements, we'll go ahead and discuss a little bit about the general structure of our programs. So we'll talk about the structure of a Java program, and then we'll focus primarily on declaring variables, being able to insert values into memory, and based on that idea, the idea of assigning values to our variables, and then also making sure that we understand the distinction between variables and literals. And then once we've gone through these 5 steps for our 5 fundamental concepts, I also want to wrap up this set of slides by talking a little bit about the history of Java and talk a little bit about the what's known as the compilation process, so the process of compiling a program. Okay, so talking a little bit about the structure of a Java program, there are going to be 3 major parts to consider about the structure of any program. So the first one's going to be the syntax and all the things that come with the syntax. So that's essentially those 5 parts that we talked about in the previous video. So this is going to be trying to address the idea of what code you wrote, and also are you following the specific rules for keywords, operators, and punctuation. The other aspect that we want to consider is the semantics. So whereas syntax is going to describe what you wrote, semantics describes the meaning of what you wrote. So there are many different ways that you could write a program that will effectively do the same thing. So there's many different routes to arrive at the same destination. So the semantics is essentially just saying, all these different programs that might have been written with maybe a different set of keywords, maybe the set of statements you wrote is slightly different, the meaning is still going to be the same. So we can have 2 programs with completely different syntax, but they could still perform the same tasks. And then the last part is going to be the style. So how does that code actually look? This is going to be dependent on factors that don't really affect how the program runs. Instead, they just affect how the program looks to you, how readable the program is. So this is going to include things like tabs, spaces, and new line characters. So by new line characters, I mean like pushing the enter key. Okay, so the syntax is going to specify the requirements of certain characters. This will include things, when we first get started, certain characters you're going to see pretty frequently include curly braces, parentheses, quotation marks, and semicolons. The semantics are going to help to explain the meaning of that program. So if you understand the semantics, you understand what the program is actually doing. In this particular example, we've got a string that's going to be assigned to our variable message, and then we're going to take that and actually display that to the console. So there's going to be a window on our screen that we can display all of our output to. So the style is going to be reflected in the placement of characters. For example, one of the preferences that I personally have when it comes to style is that I always put the curly brace, or at least whenever I can help it, I put the curly brace on its own separate line. So as you can see, say for example, the 2 opening curly braces, there are 2 different ways you could do that. You could place those on the line above them, so right at the very end, or you can just place them on the very next line. And in a moment, I'll kind of go through this by actually demonstrating this example by writing it, compiling it, and running it. And in that particular example, I'll go ahead and show the different placement for some of these characters. These next couple of rules are primarily going to deal with making sure that your files are set up properly. So anytime that you make a Java file, you need to make sure that it has the .java extension. So the previous program, if we're looking at this right here, we see at the very top it says public class hello. So that hello that we have right there is actually going to be the name that we need to give the file that we put this code inside of. So we can see right here, it should be in a file called hello.java. And then each Java file may have at most 1 public class. So this public class hello, this is the only public class that we can put into this program. But for the most part, at least early on, the programs that you're going to be writing will just have a single file with a single public class. So the only thing that you really need to keep in mind is that the name of that class and the name of the file, those two things have to be exactly the same. So we can see that in this third rule, the name of the public class must exactly match the name of the file. That's going to include both the spelling and the capitalization. So if at any point you decide that you want to change the name of your file, make sure that you change this, this name for the class that you give it as well. And then a complete Java program must have a main method, and this main method is going to be the entry point of every Java program. So if we look right here, we can actually see that on the next key line. You'll see public static void main, and then you'll see the parentheses and this extra little bit inside of it. So that public static void main, that lets us know that that's going to be the main method. And of course, based on this rule, every one of your programs will have to have this main method. So Java is case sensitive. This means that if you specify something as being lowercase or uppercase, you must be consistent. Particularly with keywords, there's a set way that you have to write them, whether that's uppercase or lowercase. That's already decided for you. You don't really have much of a choice there. So if a keyword is meant to be either lowercase or uppercase, it must always be lowercase or uppercase. This is also going to be true for your programmer-defined names. So however you initially decide to name a particular variable, the spelling and capitalization must be exactly the same every time you use it. All of your braces, parentheses, and brackets will come in pairs. So you can see a little bit of that right here. So you can see there are two different pairs of curly braces, but there is always an opening and a closing pair. There's also a pair of parentheses in that public static void main. So you can see the opening and closing parentheses for that. You also see this again in that line system.out.println. There's another opening and closing parenthesis there. Additionally, we do actually have brackets. So if you see the word string in public static void main, we then have string and then a pair of brackets and then args. So again, there you can also see we have an opening and a closing bracket. So every time you have an opening character for any one of these, you must also have a closing character that comes with it. And then there's one additional pair that's included, those angular brackets at the very end. Right now, there's not really anything to demonstrate that. We'll come back to that particular pair of characters a fair bit later. And then finally, as I had mentioned in the previous video, statements are terminated with semicolons. This is only going to be true for statements. So you'll see a couple of different statements that are in the body. So that's going to be all those lines in between the curly braces of the main method of the hello program. So if we take a look at this again, so we'll see for public class hello and public static void main, these are not actually statements. What these are known as is headers, and these do not have a semicolon. But if we look at the three statements inside of the main method, the string message and then message equals and then system.out.println, each one of those three lines, those are statements, and those will be ended with a semicolon. Okay. In addition to code, your programs can also contain comments, which are meant exclusively for the programmer. Any comments in your programs are going to be ignored by the computer. More specifically, I'll talk a little bit more about this later. These are going to be ignored by another program on your computer, which is known as the compiler. One way to indicate comments in your program is with 2 forward slashes. So we could see the indication of those 2 forward slashes. And then I've gone ahead and taken that code that we were just looking at, and I've gone ahead and added an extra part to it, where I now have included a comment, which says that we're going to declare the string message, we're going to assign a value to it, and then we're going to print it. So of course, you see this comment, and you'll probably wonder to yourself, what do all of these different words mean? What does it mean to declare a string? What does it mean to assign a value to it? And then perhaps also, what does it mean to print it? So let's start going through each one of those different parts. So the first part that we're going to focus on is being able to declare a variable. So a variable is essentially a space in memory that we're going to use to hold some data in our program. So you can think of a variable kind of like a box. The box is initially going to be empty, and eventually, at some point later in our program, we're going to fill it with some contents. And those contents that we fill it with, that's going to be the data that that variable holds. So a variable declaration tells a program to set aside some memory for that variable. Essentially, it's saying, okay, I've got this large room, maybe like a giant warehouse, and I want a place to put one of my boxes. So I've got to bring that box in and set that down somewhere in that warehouse. And so this variable declaration is how I say that I'm going to set aside some space for that box. So I'm going to set aside some memory for that variable. So we can think of a variable declaration like we're taking out one of those boxes and we're eventually going to use it. And a variable declaration is going to consist of two parts. So we're going to have a data type and we're going to have an identifier. So to address what each one of those two parts are, the data type is essentially us asking ourselves, what type of data do we intend to store in this variable? This will help us determine how much memory we're going to need, and it also helps us determine how the data should be formatted, because different data types will have different formatting. Essentially, if we were to describe this in terms of our box analogy, we would say that our boxes are going to come in various shapes and sizes to best fit specific types of data or specific contents. If we have our identifier, our second part, this is basically just the programmer-defined name. So what name do we want to give this variable? So the identifier given to the variable is simply a name for that storage space. So again, using our box analogy, in order to stay organized, we want to make sure that we've added some labels to our boxes. That way then, whenever we want to go get a particular box that has some specific contents inside of it, we know exactly which box it is because we can just read the label on the side of it. So to give you an example of this, we'll consider two different variable declarations. So the first one is essentially what we already saw. We're going to have a string that we call message. So a string is essentially just a sequence of characters. You can kind of think of strings as being like the text, or in terms of novels, it'd be like the dialogue of your program. And then the second declaration we're going to have is going to be for an int, which is short for integer, and we're going to call this one number. And an int, since it's just short for integer, basically is just any numeric value that doesn't have any fractional or decimal portion to it. So then at the very end right here, we see we've got our string message and then our semicolon. So that's going to be our declaration. We've got our data type of string, and we've got our name, our variable name of message, and then our semicolon. And then for the second one, we've got int, so that'll be the data type, and then number, that's going to be the variable name, and then we've got our semicolon. And then to represent this with that box analogy, we've got two different boxes. Each one is going to have its own size, since these are two different data types. The number one we've placed on top, slightly smaller, and then we've got message, a much larger box, underneath it. Alright, so we've got a set of rules that we have to follow when it comes to our programmer-defined names. So taking, for example, the identifiers for those variables, those will have to adhere to the set of rules. The first character will need to be a lowercase letter, an uppercase letter, an underscore, or a $sign. For most of the variable names that you're going to come up with, you will typically just use letters. So underscores are typically used for what's known as pre-processing, which is not something that we're going to be doing. And $signs are more commonly seen either in certain areas of JavaScript or in PHP. And since we're not going to be working with either of those languages, we're not going to worry about that either. So primarily, we're just going to focus on the upper and lowercase letters for our first character. And then every character after the first character can be anything that was listed above or we can start using digits. So we can have 0 through 9. So the only rule really about 0 through 9 is that we just can't make them the very first character. Additionally, just like our keywords, our identifiers are going to be case sensitive. So if you choose to give it a lower or uppercase letter at some point, it has to always be that. It needs to be consistent. Additionally, we can't have any spaces. So whenever we come up with a variable name, if that name is going to span multiple words, you're going to have to just kind of combine those words together. You can't have any spaces in between them. And you can see a few examples that I've included here where I kind of move away from the syntactical rules and I get into what's better described as best practices. So there are two different kinds of casing that we're going to see. So we're going to see what's known as camel case for variable names. So with camel case, the way that this works is the very first letter is always going to be lowercase, and then the first letter of every word after the first word is going to be capitalized. So if we see things like day of week or miles per hour, if we're using these as variable names, then the D in day of week is going to be lowercase, but then the O and the W will be capitalized. For miles per hour, the M is going to be lowercase, but the P and the H are going to be capitalized. Then there's Pascal case, which is kind of like camel case, except now the very first letter, that very first character, will be capitalized. So we can see that typically for class names. So if we use this example previously, you'll notice that for public class hello, the class name hello, the H is capitalized because I'm adhering to Pascal case for that. And so I've got a couple more examples right here. I've also included hello world, so we can see both the H and the W are capitalized. And I've also included person, where we can see that the P is capitalized. So it's important to remember for these last two bullets that I've included, these are not syntactical rules. You don't necessarily have to do things this way. And if you choose not to do things this way, it's not going to prevent your program from running properly. It's just highly recommended that you do this because these are best practices. The majority of people that write programs tend to follow these rules. Alright, so now that we've talked a little bit about declaring our variables, now we'll try to start adding something into those variables. So we're going to talk a little bit about inserting values into memory. So if a value is going to be inserted into these variables, you can kind of imagine this like inserting some contents into your boxes. So given those two cases that we looked at before with number and message, we know that number is of type int, so the only things that we could put in there are going to be numbers that don't have a decimal portion, say like the number 25. And then for message, we can put strings into those, so sequences of characters. And the best way that we can recognize that something is a string is by using those double quotes. So you can see that right here. If I go back to that example piece of code, if you notice, in the second statement in our main method's body, we say message equals hello world, and the hello world has those double quotes around it to indicate that that's a string that we're trying to put into our string variable. So we'll go ahead and take each one of those and say that we want to try to place those into those boxes. So then, of course, the question is, what is the way that we go about writing a program or writing a line of code in our program to do this? So this is where we get into assigning values to variables. So this is where we bring up that assignment operator again. So values are going to be assigned to variables by using the assignment operator. So we've got message equals hello, and then we've got number equals 25. So these two lines are showing how we would go about taking those values and putting those into our variables, or essentially taking those contents and putting those into our boxes. So the variable, in this case our box, is located on the left-hand side of the assignment operator. That will always be the case. The thing that you're trying to put something inside of is always going to be on the left-hand side. And then the value, the thing that you're trying to put into it, is always going to be on the right-hand side of the assignment operator. So once a variable has a value assigned to it, other operations could then be performed using the variable as if it were the value itself. So anytime that you want to access the hello that's inside of message, you can just use message. Or anytime that you want to use the 25 that's inside of number, you just use number. For example, we can go ahead and place those into the those print statements that I showed before, so we can actually print those to the console. So we've included two statements here where we did that system.out.println. The first one, I'm putting message in there, so we're going to go ahead and print the word hello to the console. And then for the second one, I'm putting in number, so we're going to print out the number 25 to the console. Alright, so one last component when it comes to the structure of our programs that I want to cover is the distinction between a variable and a literal. So a literal is another way to describe the values that we assign to our variables. So if we deal with numeric values without any decimals, say like the number 25 that we saw before, that would be an int literal. Any value that we use double quotes around, that's going to be a string literal. So if you had wanted to, you could actually swap out the variable with the literal. So for example here, instead of using system.out.println message, you could just replace message with the value that it holds and just use the literal itself. So you could just say system.out.println and then hello. One key thing to keep in mind is that message is a variable, so we don't put double quotes around it, but hello is a string literal, so we do put double quotes around that. Another thing to say about variables and literals, we can actually go ahead and declare a variable and assign a literal, so we assign a value to it, all in a single line of code. So if we wanted to, we could actually go ahead and say string message, so that's the declaration, and then say equals the string literal hello, so that's the assignment. And we'll just go ahead and do that all in one line of code. Additionally, we can do that with our int data type, so we can say int number, that's our declaration, and then we can say number equals 25, that's going to be our assignment. One thing to note about doing this, the very first time that a value is assigned to a variable is what is known as initialization. The reason that we call it initialization is because this is the initial value that we're giving to that variable. So the very first, or the initial value that we put into message is the word hello, and the very first, or the initial value that we've got for number is going to be the value 25. And it's important to keep in mind that once we've decided on a data type for our variable, that the contents, the values that we try to put into that variable, are consistent with that data type. So once a variable has been declared, the data type indicates the values, the literals, that we can assign to that variable. So this first line right here shows int number equals 5, perfectly fine, but one thing to keep in mind is that the variable number can be assigned a literal int, but it cannot be assigned a literal string because the data type of number is int. So the following line would cause an error. So if we try to use 5 with those double quotes around it, indicating that it's a string literal, that's not going to be allowed because number is expecting an int, not a string. Another thing that I want to go ahead and say about assigning a value to a variable, we can also go ahead and take a value that's in one variable and assign that to another variable. So similar to the relationship between variables and literals, both variables must have compatible data types. So in this case, I'm just going to be working with two ints. So we have number and second number. You'll notice that the data type for both of these is int, so they will be compatible with each other. And on the first line, I've gone ahead and just done the same thing that I've done a couple of times now. Say int number equals 25. So we'll go ahead and declare an int variable. We'll call it number. We'll assign the value 25 to it, so that'll be initialized. And then in the second line, I have declared another int that I call second number, and I'm going to assign number to second number. So in this case, as I mentioned before, if we use the variable instead, it's basically just going to take the value that's in that variable and use that in its place. So in this case, number holds 25. So we're going to take that 25 and we're going to put that into second number as well. So effectively what this does is it copies the value from one variable into another. So now the variable second number will also hold 25 inside of it. And we can see a little kind of graphic right here where I'm showing number, so a box called number with the value 25 inside of it. And we're going to take that 25 and we're going to copy that into another box called second number. Alright, so at this point, before I get into this, we'll go ahead and take a moment to actually demonstrate what we've seen so far in code. So we'll go ahead and break away from this, and then minimize that. And if you've already set up NetBeans, you can go ahead and access that. So we'll go ahead and open that up. And then when you first open up NetBeans, you'll see some kind of start page. You can go ahead and close that. And then what we're going to go ahead and do is make a new NetBeans project. So the icon that you want to click on is going to be this sort of orangish folder right here with a plus sign next to it. And when you hover over it, you'll see that it says new project. Go ahead and click that. We're going to make sure that this is set to Java for the category, and for the project, it's going to be a Java application. We'll go ahead and click next. Right here, we're going to go ahead and give this a name. So for this one, I'm going to go ahead and demonstrate that hello program that we saw before. So for the project name, I'm going to call this hello, and also make sure that it has a capital H. Go ahead and click finish. And once this is finished, it's going to show my project right here. So you'll notice a couple of different things. You'll see right here at the very top is the overall project itself. Inside of that project, it's going to have what are known as source packages. So this is where all of your source code is going to be located. And it's going to be broken up into what are known as packages. Essentially, packages are just folders. So in this case, we've got a folder. It's called hello. This name is based on what we call the project. The one difference is that for this package name, the H is going to be lowercase. And then inside of there, this is where we actually get to the part of this project that we're concerned with. We see the Java file for it. So the Java file, the name of that, again, will also match with what we called the project. So it's going to be hello with a capital H, and then we see that .java extension. The actual code inside of it, so we've got quite a bit going on right here. You'll mostly notice a lot of things that are kind of grayed out. These are all going to be comments, so we're not too concerned with any of those. So what I'm going to go ahead and do is actually remove most of these comments. So I'm going to go ahead and delete all of this. Leave this statement right here at the very top. I'm going to remove this. Move that up. To follow the style that I typically use, you'll notice that by default, when it first creates this hello.java file, it's got public class hello, and then the curly brace is at the very end. So as I mentioned before, you can choose to do it this way. It really depends on what your preference happens to be. My preference is to just go ahead and move that to the next line down like this. We'll then go ahead and remove this comment as well. Move that up. Same thing right here. So we'll see at the end of our public static void main, we've got another curly brace on the end of the line. I'm going to go ahead and just move that to the next line down. And then right inside of here, so in the body of the main method, between those two curly braces for it, this is where we're going to go ahead and add in those statements. So they usually leave a little to-do stub right here that tells you that your application logic needs to go here. It just means all the code that you're going to write. So we're going to go ahead and remove this comment. And we'll go ahead and add in each one of those statements that I mentioned before. So the first one is going to be our variable declaration. So we're going to put in the name string. We're then going to go ahead and give it a variable name. So we'll call it message. And then at the very end, because this is a complete statement, we'll have a semicolon. Okay. We'll then go ahead and push enter. And then on this next line, this is where we're going to go ahead and assign something to message. So we're going to take that message that we have. We're then going to use the assignment operator. So we'll have that equals. And then we're going to have our pair of double quotes. So if you add just the opening double quote for it, it's immediately going to generate both of them. So it'll just immediately give you the closing one. And then you're just expected to fill in everything that goes inside of them. So in this case, we're going to put in the phrase hello world, and we'll have an exclamation point on the very end. And then again, because this is a complete statement, we want to make sure that we have a semicolon on the very end of it. And then for this third line, what we're going to go ahead and do is create that print statement. So we'll have system. Keep in mind that system will have a capital S. This is going to be dots. Then we're going to have out. And you'll notice that it kind of tries to autocomplete some things. I'm not going to worry too much about that right now. So we'll have dot out. This out is going to be all lowercase. And then we're going to have that print line. So we'll have print and then LN. And then we'll have our pair of parentheses. Again, it's going to go ahead and fill in most of the rest for us. So it's going to give us the closing parenthesis. And in this case, it's also going to give me the semicolon at the very end. And then what I'm going to go ahead and do is put the variable that I want to print out inside of this. So we're going to put in message. Okay. We'll then go ahead and save this. So we've got our little save icon right here. You can click that. You'll also notice whenever you save a Java file, if you have unsaved changes in your Java file, this title is actually going to be bold. So if I add something like this, you'll notice that the hello.java becomes bold. I'm just going to go ahead and remove that. We'll click save again, and then it'll change back to being unbolded. The next thing I want to go ahead and do is actually try to run this program. So in order to do that, if you want to try just running the project, you can just click on this button right here. It'll also show you, if you hover over it for a moment, the hotkey for this, which is F6. So if you push F6 on your keyboard, that will also make it run. And so then when it runs, you're going to get this little output right here. So this is the console window. So I mentioned before that whenever you have something like println, that this is going to print to the console. This window right here is that console window. And so if we look inside of here, we can see the phrase hello world being printed to that console. Okay. And so this is what happens whenever your program runs successfully. So you can see build successful right there. If, on the other hand, you mess up something inside of it, say, for example, you forget a curly brace and you try to save the program and then run it like that, it'll tell you various warnings. So in this case, it's going to warn me that there's no main method. So let's say maybe we forget a semicolon right here. And maybe we also mess up the name of it. And we try to run that. It will prompt you, letting you know that your program is compiled with errors. It'll ask you if you'd like to try running it anyway. I will recommend now that you never checkmark always run without asking. If your program compiled with errors, you definitely want to go ahead and stop and check to see what the problem is. But let's go ahead and run it anyway and see what happens. So if I do that, it's going to give me a bunch of red text and a whole bunch of warnings. The primary thing that you're going to be looking for whenever you see this is going to be a line something kind of like this. So you'll notice right here that it's telling me two things that are very useful. The first is that it's telling me exactly which file is giving me the error. So in this case, we're only working with one file, so that much is pretty obvious. The second thing that it's warning me about is the line where it encountered an error. So in this case, if you look right here, you can see these line numbers. So right here is line 6. This next line down is going to be 7, and then line 8. So that's giving me a warning about line 8, which would be right here. So if we check right here, we might notice that there's nothing really wrong with it, but you might also notice a couple of different error messages that it's displaying here, particularly this one. So if we use this one, it's going to give us this little hint telling us that it was expecting a semicolon. So if we come over here and fix that, we can go ahead and at least correct that error. Go ahead and save that. Try running it again, see what other kinds of errors it gives us. So again, compiled with errors. We'll just try it anyway, see what happens. Again, it's giving us a warning about line 8. So now if we go ahead and take a look at line 8, the issue, it's kind of marking it for us. It's showing us that there's a problem with message, and not only on line 8, but also right here on line 9. And the reason that it's doing that, as I mentioned before, is we've got a programmer-defined name, which is message, but the spelling that we've used for it is not exactly the same everywhere in our program. So when I declared it, I accidentally forgot the letter E on it. So if I want to actually use it, I've got to make sure that that name matches. So one alternative is to just make the name match everywhere like this. The other alternative is to just do the opposite. if we notice that we've misspelled the name, we can just go ahead and fix that here. Okay, so we'll go ahead and do that, and then we'll go ahead and save it. And then, of course, if we run it again, now we can go ahead and see it building successfully again. So that's just to give you a general idea about kind of a brief introduction to being able to debug a program with what I think are some pretty common errors that you might run into, which is misspelling variable names or forgetting semicolons. So those would be two things that you'll probably become very accustomed to as you try to write some programs. Alright, so now that we've covered all that, we'll go ahead and jump back into the slides. So, continuing on, the next thing that I want to talk a little bit about is going to be secure variable declarations. So, whenever you declare variables, you want to make sure that your declarations are clear, concise, and consistent. So, whenever you're declaring multiple variables, so say maybe we have several variables that we're going to use in our program, so we want to go ahead and declare all of those at once. We want to make sure that we're using a uniform declaration and initialization. So whatever we do for one, we should do that for all of them. Each one of our declarations should be on its own separate line, and we should also include some descriptive comments whenever necessary. So maybe if we're dealing with a particular variable whose purpose we don't immediately recognize, say maybe we worked on a project, a particular program at one point, we close that program, we come back to it like a week later, we look at the variables and we wonder why did I put that there? Probably a good idea to include a comment letting you know why it's there. So we've got an example right here, and a question for you: how can the following example be improved upon to enhance the security of this variable declaration? So we've got our int bonus is equal to 205. I've then gone ahead and added two other declarations and assignments. I'm doing it as a comma-separated list. So because of the way that I've set this up, bonus, balance, and interest are all going to be ints, so they're all going to use the same data type. Bonus is going to have 205 assigned to it. Balance is going to have 95 assigned to it. And then interest at the very end doesn't have anything assigned to it. So what are some of the things that you could do to improve upon this example to enhance the security of it? So to make this a bit more interactive, if you want, you can go ahead and pause the video for a moment and kind of think through a couple of the different things. I'm then going to go ahead and move on to the next slide to actually work through the couple of things that I've added to it to improve the or to enhance the security. So the variable declarations will need to be moved to separate lines, so we don't really want to use a comma-separated list like that. And each variable is going to be initialized to keep the structure of it uniform. So if we're going to do initializations for bonus and balance, we're also going to go ahead and initialize interest with some value as well, just to keep it consistent. But since interest originally had no initial value, it might be a good idea to go ahead and give it some kind of dummy value. So we're just going to start off with 0 initially. We've also gone ahead and added some comments to improve our understanding of each one of these different variables. So for this, we've gone ahead and included a comment that clarifies what the meaning is for each one of these three variables. And so the way that I've done this, you'll notice that I'm using the 2 forward slashes at the end of the line. So another thing to note about writing comments this way is that in addition to being able to write them on their own separate lines, you can also write them at the end of a programming line. So I'll take a quick moment to just go ahead and add these 3 lines to our hello program. We're not really going to do anything with them. It's primarily just going to be there as an example. So we'll go ahead and minimize this, and we'll go ahead and open that up real quick. And so right here, we've got our 3 lines already, and above these, I'm going to go ahead and add in those 3 variable declarations. So one more reference to them, make sure I know everything. So we're going to have a bonus, a balance, and an interest, and it's going to be 205, 95, and 0. So we've got a bonus, which is going to be equal to 205. We'll have a balance, which is going to be equal to 95. And we're going to have an interest, which is equal to 0. Oops, 0. Okay. So in this particular case, for this example, I'm just going to write out the declarations and initializations. We're not actually going to use them. So because I don't actually use them, or they don't really do anything meaningful, I am going to get a warning. So it's a warning, not an error, right here, telling me that this variable is not used. You can pretty much ignore this. And of course, if you're writing a program and you see this, it's either a premature warning, meaning that you do intend to use it, you just haven't used it yet, or if you've already completed a program and you're still seeing this message, you probably have a few extra variables that you didn't actually do anything with. In addition to this, we'll go ahead and add some comments. So the way that I'm going to add these comments to kind of keep them lined up at the end of each of these lines, I'm going to go ahead and just do a tab once. We'll put in our comment, and let's see, the first comment is going to be bonus pay for employees. So go ahead and add that comment right there. We'll move to the next line. We'll go ahead and tab this. We'll add our 2 forward slashes. We'll then go ahead and get the next one, which is going to be the current balance in a bank account. So we'll say current balance in a bank account. Whoops. And then for this last one, for our interest, again, we'll go ahead and tab once, add our 2 forward slashes, and then add our comment. And this is going to be the interest for a savings account. Add that last comment there, and there we go. So this is showing essentially a secure variable declaration for these 3 variables. For perhaps some other additional program we might include that deals with things like employee pay, and then being able to track their, maybe for a single employee, being able to track their bank account information, perhaps for your own personal use. And then we'll also go ahead and save this, and we'll keep that around as a reference. Alright, so now moving on. The next part that I'm going to focus on to finish this up is just going through a brief history of the Java programming language and talking a little bit about the compilation process for Java. So in that compilation process, I'll also talk a little bit about the environment for Java, so cover a couple of the different tools that are available. All right, so Java was initially developed by James Gosling. So it was him and a team of, I think, a few dozen, maybe it was only about a dozen software engineers that worked on the Java programming language in 1991. The original project, Oak, was focused on developing a programming language and environment that would offer strong platform independence. So initially, when they were working on this project for those first few years, primarily the reason that they were aiming for strong platform independence is because they were trying to develop this as a language that could be used by multiple different household appliances. There's also some experimentation with using it for cable boxes. When it came to household appliances, they were aiming for smart appliances. This is fairly similar to the Internet of Things that we see today. Ultimately, these ideas were a bit ahead of their time, so they weren't really commercially viable. There wasn't really a market for them. It wasn't until 1994, so a few years later, with the advent of the Internet, that Java became a strong candidate for use alongside web browsers because of that platform independence that it offered. So because of the fact that many different types of computers were using the Internet, each one with its own operating system, it was very important to make sure that web browsers, including any of the software that ran on those web browsers, was capable of being ran on multiple different platforms. So in 1995, the latest version of the Netscape browser was actually using Java programs. So that was the point at which Java became more commercially viable. So there's a couple of different components to break down when it comes to using Java. So if you've already downloaded NetBeans and you also got Java 8, it's better to say that the thing that you got is the JDK, which is known as the Java Development Kit. So this basically comes with all of the software that you will ever use for essentially what I would describe as that Java ecosystem. So in this this graphic that I've included, we show the JDK as being this outermost box with everything else contained inside of it. You'll also notice things like Java jar, Java, etc. Those are referring to commands. So if you know a little bit about using the terminal for your computer, you would actually be able to use those commands. Maybe not initially. There's a little bit of additional setup that you would need to go through, but those are usable commands for compiling and running your programs. So essentially doing everything that we do in NetBeans, but in a more manual kind of way. So the JDK is also going to contain the Java runtime environment, which is the JRE. This consists of the various tools necessary for running your compiled application. So if javac, that Java C command that you see in the JDK area, is used for compiling your programs, the Java command, the very first one that you see inside of the JRE box, that's used for running your compiled application. And then inside of the JRE, so if we go one layer down from there, we have the Java Virtual Machine, or the JVM. This essentially acts as a container for running your application. So this JVM, this is the reason why Java is platform independent, is because the way that Java programs actually work is that they don't really run directly on the hardware of your computer. Instead, there's a little virtual machine that is set up, and then the applications run through that. And then inside of our JVM is going to be our JIT, or just-in-time compiler. Essentially what that's going to do is once we've got our compiled program that we're trying to run, it's going to go ahead and take that compiled program, that compiled bytecode, and it's going to go ahead and compile that or convert that into native machine code. And so when it says native machine code, what that means is that now that's the part where the JVM is going to go ahead and send some of the stuff outside of it so that it can actually be ran on the hardware. So to kind of break this down a little bit further so that maybe it makes a little bit more sense, the general purpose nature of Java is achieved through the compilation of your Java source code into bytecode. Then this bytecode can be executed on any machine that provides a JVM. So our Java source code, that's going to be everything that is inside of our Java files, so things that use that .java extension. This bytecode that I'm referencing every once in a while, whenever you compile your Java source code, that's actually going to make new files, which are known as class files. So they use a .class extension. Those are going to contain your bytecode. And so then whenever you're trying to actually execute your program, it's going to take those class files and run those through that JVM. So then, of course, if you wanted to actually do this through a terminal, to briefly talk a little bit about this, again, make sure that the name of the file and the public class match exactly, and make sure that there is a main method. That's going to be the entry point of your program. You're going to first use javac. So that's going to be the command that you would use in your terminal. Or if you're doing this from Windows, you might think of that as like the command prompt or the PowerShell. So we're going to do javac, and then you're going to have the name of the file. It's going to be hello.java. So it's just like that Java file that we wrote. And then once you've executed that line, it's going to go ahead and compile your Java file into a class file. And then you're going to use Java and then the name of the class file, which is going to keep the same name as your Java file. The one difference is that it's going to have that .class extension. So if we kind of step through this right here, the first command compiles the Java file into a class file. The second command executes the newly created class file. And whenever we do that, the .class is implied. So in an IDE like NetBeans, you can pretty much ignore almost all of what I've talked about because it's going to do pretty much everything for you. Whenever you run a program, it's going to handle both the compilation and the execution all at once. There is an alternative, which is building or cleaning and building a program, which will specifically handle the compilation step. So I'm going to take a quick moment to demonstrate this. So if we come back into NetBeans, if we notice right here, in addition to being able to run the program right here, if we move over to these, you'll see a hammer, which is for building the project, and it's going to show the hotkey F11 for that. And then there's also clean and build project, and the hotkey for this one's going to be Shift plus F11. I should also note that these are going to be the hotkeys for Windows. If you're doing this from a Mac, the hotkeys will be slightly different. So let's use clean and build as an example. So I'm going to go ahead and click this, and we'll take a look at what happens. So when we do this, we'll notice that it goes through the entire building process, and it kind of gives us a little rundown of the different steps that it had to go through. So you'll notice right here it says compile, and then it kind of steps through all of the compilation. And then it also handles another process that I won't go into too much detail about, which involves creating what's called a jar file. And so once we've done all that, then of course we could go ahead and run it again, and we can go ahead and get it to print out all of the output that we've been getting before. So the best way to summarize this, what's really convenient about the way that Java works, is that once you've compiled it into its bytecode, those class files, then because of the JVM, you can go ahead and take those class files, and as long as you have a machine with a JVM on it, you can execute them essentially anywhere. So that's how Java is able to achieve its general purpose nature, its platform independence. All right, so at this point, this is going to wrap up everything for the fundamentals of fundamentals. So we've gone through quite a bit with this video, talked a little bit about variable declarations and assignments, as well as being able to do both with variable initializations. We talked a little bit about secure variable declarations with keeping them on their own separate lines, keeping them uniform, occasionally using comments as needed. And we've also addressed a little bit about the history of Java, as well as talking a little bit about the compilation process. So at this point, going forward, we're going to start looking at more characteristics about our Java programs. So obviously there are a couple of other statements, even just in this file alone, that I haven't really touched on all that much yet. So moving forward, we want to start discussing some of these other lines in more detail, and also making sure that we understand even more about the lines that I've already covered by introducing even more concepts in the fundamentals of Java.